Okay, welcome back. Here we are at our last video for series parallel circuit faults with multiple components in a parallel circuit, and we're going to look this time at a changed value. So we are going to make R4 an adjustable resistor and change its value from 4.6 k ohms to 100 k ohms. And this is mostly so that we can really get a big picture of what large change values in a resistor looks like in our whole circuit. And really, when you talk about resistors faulting and changing values, it's much more common to see them gain in value because they are deteriorating, and at some point they would become an open. But so this is not an unusual circumstance, even for a fault. It might be a little bit extreme for a variable resistor, but still a good example. As you look at the current paths, you can see that we still have current in both of our branches, so current paths haven't changed. Let's take a look at resistance. So we know it was the original 13.33K. We are expecting that to go up because of the much larger resistive value of R4. So let's take a look at the numbers. So here we go. We take our reciprocal of our 5K ohms, which is our R3 in branch 1, and our 105.4K ohms, which is the total resistive value of R4 and R5 in branch 2. And we do indeed get a larger resistive value for our parallel of 4.77K ohms. So when we go to put that into our total resistance, we add it to our two series resistors, and we find that resistance has gone up to 14.77K ohms. So it's gone up almost 1,500 ohms. All right, so now if we see that resistance has gone up, we can look at our Ohm's law arrow theory. If voltage remains the same, resistance goes up, we expect to see our total current go down. So when we look at our total current, it was 3.75 milliamps, and of course that'll change. It's now our voltage divided by our new higher resistance, and we see that current has indeed gone down. It was 3.75 milli, now it's 3.39 milli. So it's gone down a little less than half of a milliamp. Okay, so from what we know of doing our voltage drops for our series and our parallel from the previous two videos, we're expecting our two series resistors to follow total current and go down because their ohmic values have not changed. Alright, so we did have 9.38 volts for R1, and we see with the smaller current, it has indeed gone down to 8.48 volts. We look at R2, it was 28.13 volts. And with that smaller current, it is now 25.43 volts. So both of those have indeed gone down. Now with the much larger resistive value out on our parallel circuit, we are expecting our REQ, our EREQ to have gone up. So it was 12.49 volts, and we see that now with that larger ohmic value, it is 17.17 volts. And I'm going to throw those arrows up on the board, the ones we just talked about, and we see, of course, that it is following along with what we have learned on how faults in a circuit affect other components. All right, let's take a quick look at current. So, of course, both branches still have current, but it's way different than it was originally. So that's the original branch current for branch 1. And now, with a larger voltage, we see that the branch current has gone up. And now we look at the other branch, it did originally have 1.25 milliamps, and with a much larger ohmic value, even though voltage has gone up, we see such an increase in the ohmic value that our current has gone way, way down. So it's an interesting look at how ohmic values and voltages and change currents. So for instance, in branch 1, which didn't have an ohmic value change, only had a voltage drop change, we see that current has gone up. If we were to go back to our Ohm's law arrow theory, voltage has increased, resistance has stayed the same, so we would expect current to go up. That is what's driving, right? And so when we look at branch 2, we see it's a little harder to see in branch 2, honestly, because we see voltage has actually gone up, but so has resistance. And so if you're looking at your arrow logic, you would expect current to stay the same. But in actuality, because the ohmic value has gone so far up, it has so far exceeded the increase in voltage, that we actually see current having to go down to balance that equation out. So it's an interesting look into arrow theory and faults and what happens in your circuits. So arrow theory is a great start for simple circuit faults to try to figure out what's going on in your circuit. But just remember, those ohmic values are really affecting your voltage drops because they are so large, and they're affecting your currents a lot of times because they're so large. Whereas your current is a much smaller value. And so proportionally, in electronics and math calculations in electronics are really all about proportions. So proportionally, that ohmic value is going up so much more than current goes down. And so what happens with your ohmic values is really a driving factor in what you see in your math calculations for your electronic circuits. And we're going to explore this some more when we get out into our RL and RC circuits. All right, and we are getting way over on time. I hope you enjoyed this section on series parallel circuits. I'm going to post some stuff next on bridge circuits and voltage dividers.